Welcome to absolute value and radicals for Pre-Calculus Math 11. Today we're taking a look at absolute value of a real number, which is section 2.1. Basically, every real number can be represented as a point on the line. And really it's the sign of the number indicates its position relative to 0. So negative is left of 0, positive is to the right. I think we have this pretty good understanding that negatives are further left, positive is further right. The magnitude, that's a term you may want to remember, the magnitude of the number indicates its distance from 0. So you'll see that in physics as well, that term magnitude, particularly with vectors. For instance, on the number line below, each of the numbers -4 and 4 are located 4 units from 0. This distance of 4, regardless of direction, is called the absolute value. So absolute value of the number. So what we see here is this distance here from -4 to 4. If we just count how many slots that is, how many spaces, we see we got 4 units. Same thing from 0 to 4, we have also 4 units of space. So what that tells us is the absolute value notation is written as, well, if we have -4 and we take the absolute value of it, we're basically just making it positive. -4 becomes +4. And we can see that absolute value of +4, since it's already positive, just remains +4. So really pretty straightforward concept, I think. If a number is positive, it remains positive. If a number is negative, you make it positive. So absolute value of 3.7, since it's already positive, that just remains 3.7. Absolute value of -17.2, because it's negative, we make it positive to make it positive 17.2. Now here's something we didn't discuss, absolute value of 0. Let's think about this. Absolute value represents the distance away from the point 0, or the magnitude of the distance. So if we're on 0, our magnitude of the distance must be 0. So absolute value of 0 is also defined. Absolute value can also be used to determine the distance between 2 points on the number line. As a first step, consider just counting the number of units between the 2 points. Let's take a look at -3 to 5. So from 3 to 0, we have 3 units. From 0 to 5, we have 5 units. So not really a big surprise there. We're talking about 8 units between -3 and 5. But how can we formalize this? When we calculate the distance between 2 points, we're able to simply subtract the two values. And since the distance is always positive, it does not matter which point we start with. Remember to always take the absolute value. So absolute value just allows us to not worry about which point we start with first. So are we going to say, let's take -3 and subtract -5, then take the absolute value of that? Or are we going to start with 5 and subtract off -3 and take the absolute value of that? Both of those will give us 8. Let's say we want to use absolute value to determine the distance between -5 and 2. Sketch a number line to illustrate your solution. Why don't you go ahead, hit pause, see if you can do this. Basically very similar to the question we just did above. So, if we want to find the distance between 2 points, we merely need to subtract the 2. -5 minus 2, but again, make sure we take the absolute value of that. -5 minus 2 is -7, and absolute value of -7 is +7. We can indicate this on a number line. I'm not going to be terribly precise here, but there's 0, there's 2, and there's -5, and we're talking about this distance between the two being 7. Fairly straightforward, I think. Let us consider a definition of absolute value that uses operations that we already know. So we know that we can introduce this new notation, absolute value. I want to see if we can link it to something that we already know. Let's consider the number 9. It has two possible square roots. You could either have a square root of +3 or a square root of -3. We use the term principal square root to indicate the positive root. So when you square positive 3, it becomes 9. When you square negative 3, it becomes 9. But we always take the principal square root, which is the positive root, so the positive 3 from above. Since the principal square root of a number is always positive, we can use the square root of a square to represent absolute value. Now that's a whole bunch of math lingo to basically say that if we start with a number, square it, then take the square root, we guarantee that it's going to be positive 9. So if we take 9 and we square it, it becomes 81. If we take the principal square root of 81, which is 9, we end up with, for sure, a 9. And in general, absolute value of x can be written as root of x squared. So this is a way that we can maybe not simplify, but do some of these things a little bit differently instead of evaluating it wholeheartedly. 8 minus 12 squared. So 8 minus 12 is negative 4, and that's squared. I see this is very similar to the notation I was using above here. Very similar to this kind of notation, that the square root of a negative number squared should just give us the absolute value of that number that's inside, which is 4 in this case. We can extend this to some other questions, just thinking purely in terms of absolute value. Without a calculator here, absolute value, negative 15 plus 7 is negative 8, minus 3. 6 minus 12 is also, negative 6. We need to think of absolute value lines notation basically like brackets. If we think about bed mass, the bracket, the B part of that, we think of as absolute value signs as well. So we need to deal with everything that's inside of an absolute value first. Absolute value of negative 8 is positive 8. Minus 3, absolute value of negative 6 is 6. That's 8 minus 3 by 6 is 18. And we get an answer of negative 10. Now don't be terribly concerned that we're ending up with a negative answer. When you take the absolute value of a number, for sure it ends up being positive, but because in this question we had some subtraction after the absolute values, we could end up with a negative number. How about we see if you guys can evaluate absolute of negative 3x squared minus 5x plus 1 when x is 3. So maybe hit pause now, plug in x equals 3 and see what we get. So we start with negative 3. Always replace variables in brackets. Bed mass, we're going to square that first, so it's 9. We could multiply the 5 by 3 to make it 15 plus 1. That's negative 27 minus 15 plus 1. And negative 27 minus 15 is negative 42 plus 1 is negative 41. We're still taking the absolute value of that. And absolute value of negative 41 is positive 41. So we see a fairly simple, straightforward concept here, I think, with absolute value. We're talking about taking a number which is positive and leaving it positive, taking a number that's negative and making it positive. A fairly straightforward concept, and of course, absolute value of 0 is 0. This ends the notes for absolute value of a real number for Pre-Calculus Math 11.